Okay, Assalamualaikum. So now we look into chapter 3 for our subject. So this chapter 3 is about system memory. So previously on our chapter 1, we have covered this topic, but it's only a brief description of the system memory. So in this topic, okay, we will look deeper into the concept of the system memory. So first of all, what is a system memory? So system memory is basically an electronic component or devices or hardware that can store data, program, and instruction, and this thing waiting to be executed by the CPU. So usually the CPU and system memory will work together in order to perform a certain task requested by the user. In order for a user to give the instruction, so they will usually produce an interrupt. So like I mentioned previously, so we have two type of interrupt. We have hardware interrupt and also software interrupt. Okay, and the others you can read from the screen. Okay, for example, the roles of the memory. Okay, to store data and program. Okay, and then a memory consists of byte of data. Okay, so each storage unit in memory is called byte. Okay, and each byte will be represented by an address. So in order for your computer to work, so this data or this byte of data must be accessed using a specific identifier that consider unit to the computer, that we call it as a memory addresses. Okay, next. Okay, so for example, okay, let's say we have a seat. Okay, so a seat can only hold a person at a time. Okay, similarly with the address. Okay, so address in memory can also hold a single byte of data. A seat can be empty, and also address can also be empty. And basically, we must have an empty addresses. The more empty addresses that you have, the better your computer will run, because these empty spaces will be used for other program to be inserted into the system memory. Okay, a C also have a unique identifier, so does a memory addresses. Therefore, to access data or instruction in memory, a computer will refer to the address that contain byte of data. So this thing is similar to the concept that we have discussed previously on the chapter 1. Okay, for example, we start with an interrupt. So user will produce an interrupt. So this interrupt could be hardware interrupt or software interrupt. Okay, so interrupt we give instruction to the CPU. So what will the CPU do? First, CPU will check on this cache memory. Okay, whether the information is reside within the cache memory. Okay, and then the CPU will check in the primary memory, and then in the secondary memory. And then when the CPU found the information that we need, so the CPU will copy those information and put it into our main memory or into our system memory. Okay, this process we call it as a shadowing process. Okay, so basically we have two types of memory. We have volatile memory and non-volatile memory. So volatile memory is a memory that is a temporary memory. So the information will only be contained only if we have the electrical power supply to it. For the non-volatile memory, so it also known as a secondary storage or secondary memory, also called as a permanent memory. Okay, so the data or the information on the non-volatile memory will always be there unless we deleted those information. So for the volatile memory, for example, is a cache memory and our main memory or our RAM lah, random access memory. Okay, for non-volatile, the example is ROM, flash memory, hard disk, floppy disk, USBs, and CD-ROM, and others. Okay, so the example of memory, so basically RAM is a volatile, diskette is a non-volatile, USB is a non-volatile, CD is also non-volatile. Okay, ROM is non-volatile. Hard disk is also non-volatile. So basically, the only thing that is volatile is the RAM and also the cache memory. Okay, so rows of memory. So basically, we have four type four rows of memory. First is upgradability. So the type of RAM that we use on our computer, we determine whether we can upgrade our motherboard or also our system memory. For example, if we are using the DDR3, so if we plan to upgrade the RAM, so we must select the same architecture, which is DDR3. Okay, in term performance, so it doesn't matter if you have a big processor or a fast processor. If your system run low on a system memory, so the CPU need to wait for the system memory. Okay, for example, let's say CPU has processed one instruction, okay, and then the CPU will put the result of the instruction on the system memory. Okay, so and then the system memory will provide another instruction, and those instruction will also be carried out by the CPU. Okay, however, there is a limitation on the how much information or data that can be stored on the system memory. So whenever your operating system or your system memory has reached its limit or capacity, so your system will become slow and lag. Okay, and third is software support. Okay, so newer program require more memory than the old one. Okay, for example, whenever you buy a new software, so you be getting a minimum system requirement. So that minimum system requirement determine how much RAM is needed to run uh, uh, the application software. And lastly is reliability and stability. So usually the bad memory is leading cause of mysterious system problem. So however, whenever you start your computer, okay, so whenever you start your computer, the BIOS will check the reliability of your system memory. So if you pass the test, then you can proceed to the operating system. Okay, so this is the memory mapping. So memory mapping is the summary. Okay, so memory mapping is the summary on how your computer is currently using the system memory. So we have three categories of memory mapping. The first category is we call it as a conventional or the base memory. So basically, the content of the conventional is our system BIOS. Okay, and then the middle one we call it as upper memory. So the content of upper memory is usually the device driver. Okay, and then all memory above 1 MB we call it as extended memory. Okay, so the limit of the extended memory depend on the limit of memory that can be installed on your computer, and this thing is determined by your chipset. And then the content of the extended memory is usually a 32-bit application data, 32 or 64-bit application data. So it means that any software that you run on your operating system, so all those data will be copied and put it into the extended memory. Okay, so ROM, the system board. So ROM is read-only memory. So read-only memory is mean that a chip that can only be that you can only store data once. Okay, using the ROM, read-only memory. Usually contain for a permanent program. Consists the programming computer used to boot itself. So usually we put it as a BIOS. Okay, so for the read-only memory, okay, so usually the content on the read-only memory cannot be changed. However, nowadays we have many categories of ROM. Okay, so we have four type of ROM. Before that, the advantages of ROM is permanent and security. Permanent means that we cannot change the content of the ROM. Security mean that whenever we cannot so because that we cannot change the content of the ROM, so mean that the possibility of virus attack or any kind of alteration of the programming code, okay, can be avoided. So basically we have four type of ROM. Okay, so the first category is regular ROM. So regular ROM is usually come from the manufacturer, and we cannot change the content that reside within the ROM. So example is like the CD-ROM. The second category is PROM. So PROM is programmable read-only memory. So mean that it can be programmed but only once. So usually used to support certain hardware. The third one is EPROM. EPROM is erasable programmable ROM. So data that was stored in the EPROM can be erased and reprogrammed many times under the ultraviolet light. So the concept is similar to the concept of the CDRW. And the fourth is EEPROM. So the EEPROM is electrically erasable programmable ROM. So this using the EEPROM technology, data that reside within the EEPROM chip can be erased and reprogrammed under a software control. So example is our USB that we are using at this moment. And another thing is the SSD, okay, solid state disk, and so on. Okay, so BIOS versus CMOS. Okay, so what is a BIOS? What is a CMOS? So BIOS stands for Basic Input Output System, while CMOS stands for Complementary Metal Oxide Semiconductor. So BIOS is usually a software, while CMOS contains setting or data about the BIOS. Okay, as you can see in the screen, so BIOS is a software or instruction that is stored in a non-volatile memory area. So whenever we run our computer, the BIOS chip, okay, will perform all the instruction to find where the operating system and where all the component that is necessary to perform the startup process. Okay, while for the CMOS, so CMOS store BIOS setting, okay, contain parameters and kept in volatile memory area. So however, even though the CMOS store in a volatile memory area, however, the content of the CMOS is not lost because we have a CMOS battery that provide a backup power to the CMOS chip. So BIOS is a program, CMOS contain data. So BIOS is a non-volatile, it will stay the same. Okay, we cannot change the content of the BIOS. Okay, we can change the content of the BIOS, but we need to perform a certain process that we call it as a flashing. Okay, why the CMOS is a volatile, keep alive with the battery, like I mentioned earlier, can be changed by flashing. Why the CMOS you can change via CMOS setup. So typically 64 kilobyte for the BIOS, while for the CMOS is 128 kilobyte. However, most of the CMOS were using the 64 kilobyte chip. Okay, after a separate chip, while CMOS usually found on the sub-bridge. Okay, so RAM, random access memory. So what is random access memory? So random access memory is also called as a main memory or a primary storage. So all the information that currently being used by our computer system, or anything that you open, any software, any data, any video, or any sound that you open on your operating system, okay, will be stored in this random access memory. Okay, so this is the process of how RAM works. So this process is similar to the process that I have explained in the chapter 1. So you may refer to the to your notes on the chapter 1. Thank you. Okay, so RAM chip. So basically we have three types of RAM chip. Okay, the first is dynamic RAM, or we call it as DRAM, SRAM, and MRAM. Okay, so DRAM is dynamic RAM, SRAM is static RAM, while MRAM is magnetoresistive RAM. So what are the differences between these three types of RAM chip? Okay, so for the dynamic RAM, so dynamic RAM is usually used as a main memory. Static RAM is usually used as a cache memory. Okay, so the difference between dynamic and static. So dynamic, it has the data that was stored in the dynamic RAM must be accessed by a special logic that we call a refresh circuit. Why for the static? So static, there is no refresh circuit, so mean that it is much more faster compared to the dynamic RAM. Okay, so main versus cache memory. So what are the function of main and cache memory? So cache memory usually store frequently used data, program, or instruction. So cache memory is made up from SRAM. Why? The main memory is made up from DRAM. Okay, so main memory is much more slower compared to the cache memory because of the refreshing activity. So DRAM, dynamic RAM. Okay, so dynamic RAM or DRAMs only hold data if it is continuously accessed by special logic called a refresh circuit. Okay, so even though if you have the electrical power supplied to it, however, if the refresh circuit is broken, so the data on the RAM will lost. Okay, so we have a lot of variant of DRAM. Okay, however, this is the most common type. Okay, such as SDRAM, DDR SRAM, DDR2 SRAM, and RDRAM. Okay, so this is the thing that we call it as a DDR1, or SDRAM, DDR2, DDR3, and DDR4. So the main differences between all these technology is in terms of speed or latency. So these three example of RAM. Okay, so we have RIM, we have DIM, and we have SIM. Okay, so the oldest one is SIM, single on inline memory model. Okay, the de facto standard that currently being used is DIM, dual inline memory model, and the newest one is RIM, rambus inline memory model. However, RIM is not popular compared to the DIM and SIM, and nowadays we don't use SIM anymore. So SIM is the oldest RAM. Okay, so usually is the oldest standard. So were popular on the third and fourth generation of motherboard. Okay, so you have two type. Okay, which are 30 pin and 722 pin. So usually you need to install this in pairs. Okay, so the example 30 versus 72 pair. So the main differences between this is number of bit that can be supported by each of the RAM stick. Okay, DIM. So DIM is the de facto standard. So most of the RAM that we are using nowadays are based on the dual inline memory model standard. Okay, so usually DIM are 168 pin in size and provide memory of 64 bit in width. So we have a couple variant of DIM, okay, such as 72 pin SODIMM. So SODIMM is more outline DIM usually used on the laptop. Okay, we also have micro DIM and so on. Okay, so this example of different type of DIM technology. Okay, DDR, DDR2, DDR3, and now we have DDR4. Okay, so we can look into the notch. Okay, the location of the notch can determine the type of the DDR. Okay, and this one is for the SODIMM. Okay, small outline DIM for the motherboard. For the laptop. Okay, RIM. So rambus inline memory model. So were expected to replace the what we call it, DIM. Okay, however, the RIM is not popular until nowadays. So not so the market share for RIM nowadays not exceeding 5%. So why RIM is not popular compared to DIM? Okay, because of a massive price war during the introduction of the RIM. So at that time, the DIM, okay, was sold at or below the production cost. So mean that at that moment, the manufacturer of DIM, okay, so they are making a lot of loss, okay, by selling their product on the market price or below the market price. However, they manage to take out RAM from the market. Okay, and then SRAM. Okay, so SRAM or static RAM. So SRAM is a type of RAM that hold its data without external refresh for as long as power is supplied to the circuit. So basically SRAM is used as a cache memory. So we have three level of cache memory, level 1, level 2 and level 3. Okay, so two type of SRAM that we have is synchronous SRAM and asynchronous SRAM. So synchronous SRAM is faster and more expensive than asynchronous. Okay, why the asynchronous does not work instead with the CPU clock and is therefore slower than the synchronous SRAM. Advantages of SRAM. So first kali in term of size, it is much more bigger compared to the DRAM. The cost is also much more expensive. However, it is much more durable. It also simplicity, so mean that it doesn't need to be refreshed. Okay, the data on the SRAM doesn't need to be refreshed. Also, it is much more faster compared to the DRAM technology. Okay, so cache memory. So like I mentioned, yes, a cache memory is used to reduce average time to access memory. So it's usually store frequently used data, program or instruction. It is made up from the SRAM, so mean that it is much more faster compared to the main memory. So we have type of cache. We have three type of cache. First is instruction. So instruction to speed up the executable instruction fetch. Second is data. So to speed up data fetch and store. And lastly is translation load side buffer to speed up used to speed up the visual to physical or movement of the data. So memory bus. So what is a memory bus? So memory bus is used to transport data from one location to another location. Okay, so usually you can see the memory bus on your motherboard. Okay, so the memory bus is set of wire that is used to carry memory addresses and data to and from the system RAM. Okay, so basically we have two type, either 32-bit or 64-bit architecture. Okay, so just say you can read this by your own. Okay, so type of memory bus. So we have two type of memory bus. We have data bus. So data bus is data that you submit or you send through the memory bus. While address bus is the location where where the intended location of the data bus. Okay, virtual memory. So what is a virtual memory? So virtual memory is a situation where that happen when your computer is low on the physical memory. For example, let's say you have 4 GB of memory and you have fully utilized all the 4 GB of memory. You need an extra memory, okay, to store more data. So in order to do that, the operating system will move a page of data from your main memory into your hard disk. Okay, this process we call it as a swapping process. Swapping process we create a virtual memory. Virtual memory is like an additional memory to your computer. So usually we have two type of virtual memory, which are permanent and temporary. Okay, so temporary mean that the size will shrink and grow as Windows use it. Permanent mean that the size of the virtual memory will stay the same. So it doesn't matter how many times you restart your computer, you open your computer, the size of the virtual memory will remain the same. So that would be the permanent virtual memory. Okay, so this is the concept of virtual memory. And RAM drive. So RAM drive, we rarely use RAM drive nowadays. So RAM drive is the opposite of the virtual memory. So we make part of the RAM to store data like a hard disk. Okay, so it's the architecture of the RAM drive. Okay, troubleshooting. So this amount of problem that caused by the memory. First is we troubleshoot memory to ensure stability of the computer system. Okay, and then we check on the parity error, and then okay, sometimes electrical storm can disrupt the physical setting of the computer, so we have to check the setting one by one. Okay, and then add-on memory is being used, so you have to check the memory whether it have been resetted properly. Okay, so whenever you turn on your computer, so if you heard alarm beat on the computer, so mean that something is wrong with your system memory. Okay, and others, okay, you can read by your own. Processor memory bottleneck. So what is a processor memory bottleneck? Okay, so processor memory bottleneck is a problem that caused by the different speed of the CPU and the system memory. So before this, the CPU and system memory, they work in line with each other. However, nowadays the CPU is much more faster compared to the system memory. So the faster the CPU, the more time it need to wait for the system memory. So that we call it as a processor memory bottleneck. Okay, so routine and connector and socket. Okay, so this most people don't pay attention to the color of their memory model connector, okay, and socket. Okay, however, it is very important, okay, to know the type of connector, because sometimes if you choose a wrong connector to attach to your motherboard, so there will be a chemical reaction between your RAM slot and your RAM module. Okay, okay, and so on. So this is the rules to meet DRAM speed. Okay, first you have to put the slowest memory in the first bank. Okay, so if you have two RAM with different speed, so you must choose the slowest one and put it in the first bank. Why? Because the system memory will usually use the speed of the first the RAM in the first module. And second, you must use identical memory with your bank. So if you're using DDR4, so you must use another DDR4. You cannot mix it with DDR3 and DDR4 and so on. Okay, so how to upgrade memory? So first you must determine how much memory that can be supported by your computer. That will be determined by with the capacity of your chipset. Okay, and parity. So parity is a method of detecting error in data that have been submitted on the memory bus. So usually we have two type of parity. We have even parity and odd parity. Okay, so usually in a single data, one single data will be represented by 8 binary number. So if you have so if the RAM was set with a parity error, so you will have another number that we call it as a parity bit. Okay, so that's all for today. See you all in the next class. So if you have any problem, feel free to WhatsApp me or email me your question and so on, and then you may proceed with your group assignment. Okay, so well, whatever topic that you have chosen, okay, so you may develop your product, your courseware, your game and so on. So if you're having any problem, feel free to come and see me. Okay, thank you and have a fun.